everybody. I am trying something else new, so I am going to get live here a little bit earlier, just because I want to make sure that I did this correctly. So I am supposedly supposed to be streaming through my Facebook Free Method Videos account as well as my YouTube. And it's been a while. I actually did this last year for a couple of lessons, and then I kind of got out of the loop with it. So I wanted to kind of get that started again for this upcoming year. So I had everything set up, and I just want to make sure that I am actually live, and it doesn't seem. So let's see here. So it sees. All right. Let's see. I don't like that on that dashboard. Why is it showing for the June 7th? Hi. All right. Well, I guess that's showing up. That's good. I can see, at least on the YouTube, that is showing up. So at least I'm live on there. That is good. I don't have the dashboard features, though. So that's a little annoying that I'm kind of used to when I use like YouTube, I can kind of like pull out the chat and everything. But when I look at this feature now, let's look at this live feature. It's not showing anything that I have up there. So it's kind of a weird little thing from there. Okay, so cool. It's at least showing on my Facebook account. That is awesome. I'll take it away from there. But as far as everything on the YouTube, I guess I'll have to go and check. So either way, it's 9 o'clock. I guess I should get started. So I do have the option to pull this out. I guess it already goes live, so that's cool. All right. Let me just go and pop out the chat for the YouTube. There you go. Okay, so I got some text coming in. All right, very good, guys. So welcome, ladies and gentlemen, to the live stream. This is Open Q&A. This is week 22, and I am very excited to bring to you guys this lesson. This was the last week of school that I had to show up. I know some of you guys are still finishing everything out, and hopefully you guys will be there very, very soon. Toggle full screen. Yes, no, toggle full screen. I need to do fit to width. Sorry, wrong one. All right, there we go. So, but I wanted to thank you for you guys for a great year and following in through my content. And I will still be going live throughout the summer. I am going to be doing these open Q&As every Sunday night at 9 p.m. for those of you that like to tune in. And especially if you're taking a summer class or if you are already starting to get prepared for next year, which starting in July, I will start having content getting ready for the upcoming school year. So we are going to kind of wrap up this year for the next couple weeks into June. And then start of the year, you know, I was kind of like joke whenever I get back from vacation, like in July, I always remember like first thing I had to like go to Walmart and it would already be like back to school. And it's like, you don't even get to like enjoy a summer. It's already back into there. But I did want to kind of let you guys know a couple of the changes. So, or not really changes, but I've been really liking the Google Forms for you guys to be submitting your questions. It's very streamlined for me to be able to find what you are asking and as well as to be able to see exactly what you guys are doing. So awesome. Awesome job for those of you guys that have submitted your questions. I do apologize. There are some questions that have come in that I don't really understand what you're actually asking or they weren't really specific. So I wasn't able to include them. But I just want to let you guys know, for those of you that are following along the questions, we have a couple from Ellen here. And so typically, since I have a little extra time, I will spend doing these. She wanted to rationalize the denominator here. We had a distributive property, and then also just another distributive property one with exponents. And then we also have Andy submitted a question. It was a multiple choice question, which obviously I'm not going to rewrite, which I do got to work on that. I said I was going to do that last time, so I'll go and get to that. Then we have some limit problems from Anastasia. And then also this wasn't from Anastasia. This was somebody that did not want to put their name in there. But then also some asking for kind of me to explain the work. So I'm not sure if it was their students' work or whatever else. But either way, guys, you had a thumbnail that said the greatest gift. And that is what I wanted to kind of talk to you guys a little bit about today before I get into those questions. However, I see you, Chunky. I see you, Shaco and Don and Jake. Thank you so much, guys, for joining in. But so the The greatest gift is one of those things that I was kind of doing a little like thinking back reflection, and at this time of the year, typically I'm usually kind of going back through my end of the year surveys. I give students the surveys, letting me know, how I did, what I can improve for next year, and kind of think about that. Typically some students will give me some food or some cards, kind of the end of the year. And like this year, it was really like, we did a live stream for my students, and then we kind of like sent them an email and kind of was on their way. And yeah, it was just, just a very weird way of kind of like ending out the live streams. And or ending out the year. But one of the things that really kind of, hit me was, a lot of times when I'm doing the surveys, and I actually did a survey with my students as well, were they able to give me, a lot of students would just, that open, like, what else do you have that you guys can say? And a lot of students would just come in and, give like a thank you or, maybe some advice or whatever else. But I think one of the important things is, recognizing that when students are appreciative of the work and the time and the effort and the patience that you as teachers, put into the year. And so I can really say that, I've received a lot of great food, some really, really great food. I've received some great gift cards, but I think also that, the one thing I always miss is like students walking out the end of the year, just that simple thank you. It's not something that I'm used to every day. So it's like, hey, thank you for teaching the lesson. Although I did have a couple students that did that all the time. It was kind of cool. But really, like at the end of the year, it's like that culmination of, we're done. And you know what? I learned something. I took something from being inside of this classroom. So thank you for that. And some students, it's just as simple as a thank you. Some students write a very nice note. And that really is one of the greatest gifts that I have. I keep all of the letters that all of my students have written to me. I just pile them up. And, sometimes when I'm like cleaning things out, I go back and look at them. And it's a great way for me just to, kind of go back in time and remember how things were over certain years and to remember certain students. So I really, really do appreciate hearing from all of you. And especially for those of you online, because you guys send me messages on YouTube, you send me messages on Instagram, you send me private messages on Facebook, and it really does touch my heart to read that what some of the videos or my instruction has been able to help you guys out with. It also really makes me sad in a moment because I used to read all of my YouTube comments. I used to respond to all of my YouTube comments. It usually take me between 1 or 2 hours every single night. And, usually would happen when we were like relaxing, me and my wife at night, and we just kind of sit and watch TV, and I would just reply to comments. And that was basically what I did every single night for years and years. And it wasn't until really about last year, late last year, that it was overwhelming. I was really starting to create a lot of the content for my course, and I just couldn't do it. So I know a lot of you guys have, reached out to me, and I do apologize. I'm just unable to respond to everything that I receive as far as the messages and comments. But I still want to hear from you. And so what I did do is, if you guys go ahead and look in the description of this, channel. Oh, you guys, so I'm not under stream. So go to the other stream. So what is it doing? Math Legend, thank you so much for doing this. Crap. All right, let me see. Well, anyways, I'm just gonna go and continue on. So anyways, so what I did was I went ahead and created a Google form. And on that Google form, what you're able to do is you would be able to go ahead and submit your own kind of testimonial. So it can be a written, it can be a picture transformation, or it could also be a written transformation. Chunky, you are not in there. So it could be or a video testimonial. And so obviously, for those of you guys, I know I teach mostly college and high school students. If you're under the age of 18, there is a release form. So make sure that you go ahead and have that signed and anything else. Or you can just always write a private little message, just like a comment that doesn't need a release form from on there. But either way, guys, I do want to thank you for all the kind comments you guys have sent me. And I have read a ton of them. And I always try to respond as much as possible to all those private messages I get, because I do appreciate you guys taking the time to write to me. And however, I do also know that it is that I'm not able to get to anything. So I've really been liking the Google Forms that I've been using. And I do apologize. I think I realized that I guess my live stream was on YouTube, was in a different live stream. So the links are probably not available, nor are they available on the Facebook. This is my first time going back to using Restream. So I will go ahead and have to figure that out. I will put those links back in there. I do apologize for that. We'll probably do that at the end of the live stream. I'll probably go ahead and figure that out. But otherwise, let's go and get into the math, because that's what most of you are hopefully checking in on to kind of see, to do some math questions that you want me to go ahead and do. And then after that, we'll kind of have an open Q&A. I'll try to figure out where my YouTube audience went, and we'll go from there. So I don't want to cause any more disturbances. I know I'm going live somewhere, but it's not the live stream that I scheduled, so I'll have to go ahead and figure that out. All right. Okay, so let's go ahead and let's check out this one. So Ellen asked, how to rationalize the denominator. And there's actually two problems we're going to be rationalizing the denominator here. So the main thing, I don't know why I didn't put my thing here. There you go. So the main idea here, guys, when we want to rationalize the denominator, we want to basically get rid of the radical to be able to write our expression, especially when we have something in the denominator. We're trying to get rid of this radical expression. So I'm assuming that's what they were trying to rationalize the denominator. Actually, that's what the question was, rationalize the denominator. So what we're going to do is we're going to want to multiply this by the conjugate. So we multiply this 2y plus the square root of y. 2y plus the square root of y. Now, when you look at in the denominator, what's nice about rationalizing the denominator is that is now going to produce a, let's see, 2y minus square root of y times 2y plus the square root of y. Oops. Right? And then in the new, oops, I'm sorry. Why did I just write that out? Silly me. So when you're multiplying by the conjugate, that's going to produce a difference of two squares, which basically means that the middle term is going to add to 0. So therefore, you can just multiply the first two terms and multiply the last two terms. So that will give us 4y squared minus y in my denominator. In the numerator, this is going to be a little bit more difficult to, well, actually not really more difficult, but it's going to be a little bit more work. Times 2y plus the square root of y, or square root of y. Why am I making my y's look so bad? Okay. Now, if I was actually going to multiply this out, which is in that numerator, I'm actually going to use the box method for that, because it looks pretty crazy to be multiplying all this. So I want to make sure that I'm not going to lose anything. You don't have to use the box method. You could definitely do this. I don't think it's that difficult. But just for those of you that get a little confused when you're dealing with so many variables and you don't want to make mistakes, you can just put one term on the top of the box and then another term on the second, and you're just going to make as many rows and columns as you have for terms. 2y, and that would be square root of y. So when you're multiplying an expression times a radical, as long as it's not, they're both not another radicals, then this is just going to be 2y times the square root of 8xy cubed. This is going to be a 10y times the square root of y. Okay, so you can't multiply a number outside of a radical inside of a radical. Over here, you can multiply now the y and the y cubed. So that's going to be the square root of 8xy to the fourth. And then over here, we're going to have 5 times the square root of y squared. So we'll have 5 times the square root of y squared. All right, now I'm going to get to the simplifying here in just a second. All we know at this point is this is going to be our numerator. So we're going to have a 2y times the square root of, let's go and simplify things as much as we can here. So I can take out a y squared. So that would be a 2y squared. Actually, let's go ahead and write it in like this. So 8x y squared times y. Let's see, a plus a 10y times the square root of y. Can't really do anything with that. And then plus a square root of 8x y squared times y squared. Actually, you know what? Let's rewrite. Oh, why don't I multiply the 8s? Jeez, this is a heavy algebra problem. And then plus a 5 square root of y squared. Okay. All right, I'm going to, let's see. I wonder if I can do this. It does work. Okay, so that's everything right there. Now I'm actually going to simplify this. Remember the square root of 8? Hopefully you know that the square root of 8 is the same thing as the square root of 4 times 2. So that's going to be 2 square root of 2. Okay, so we can break down 8 as 2 square root of 2. And we can take the square root of y squared, which is going to be y. So therefore, what that's going to produce, now this numerator needs a lot of work. The denominator is just going to be set, so I'm going to keep that there. Geez, I ran out of space. I didn't think I was going to need this much space. Here, you know what? I'll do this. This is a big problem here. All right, so let's do this mathematically here. So that's 4y squared minus y. All right. So in the next round here, let's see here. I can simplify that to be 2 square root of 2. So that means there's going to be a 2 outside of the radical. So that's now going to be a 4. The square root of y squared, I can't take the square root of x, so I'll leave that there. The square root of y squared is y. So y times y is y squared. And then left under the radical is going to be a 2xy. And then plus here, I can't really do anything with this. So that's going to remain a 10y squared of y. Here I can put the 2 on the outside again. So there'd be a plus a 2. I can take the square root of y and plus the square root of y. So that's going to be a y squared. And then left in there is going to be a 2x. And then plus I can take the square root of y squared, which is just going to be y. So that'd be 5y. All right, so that was a very heavy algebra problem. Hopefully I did not make a mistake. If I did, post it in the comments, even though I can't see the comments because it's not where it was supposed to be. So actually, let me just make sure you're... But either way, I'll come back to it later and check my work. Whew. All right, that was a lot. So, but definitely, the other thing else you could do is simplify common terms. If you have any of the radicands are the same, you could look into combining like terms. But in this case, we do not have that. So we're going to move on. All right, so the next example is again a distributive property. And again, this is a very heavy algebra 2 problem because you can see that you have this expression squared, and then you're going to multiply this by v squared. So in this case, we're going to have u v squared w cubed minus, actually, you know what I'm going to do? I'm going to do the box method again because this would be a great reason to use the box method here. All right, so that's a bad box. So again, all we're doing is we're multiplying a term by itself. And these are some big terms, right? This is not something that's very typical. So I'm going to put each expression on its own column. And then I'll do it again. So u v squared w cubed, and this will be a minus 3u squared w. Okay, so when I multiply, now the nice thing about the box method is you're just going to do length times width. So we're doing length times width to find the area of the box, because that's basically applying distributive property. But as you can imagine, if you're going to do like FOIL for this problem, it is just going to look crazy, and it's very difficult to like see that. So that's why I'm going to use camera effects. I can use that. Actually, not. It says I'm live. Do I have a thing? I do not. I guess I can look at that maybe. I don't know. All right. So anyways, let's go through this. So I have uv squared w. So u times u is u squared. V squared times v squared is v to the fourth. Again, remember when you're multiplying exponents, you're going to be adding the powers. W cubed times w cubed is going to be w to the sixth. Now I have this times this, so I'm going to do my height times width. So that's going to be a negative 3. Let's see, u cubed v squared, and that would be w to the fourth. Over here, it's basically going to be the exact same product, right? It's the same thing, so I'll just recopy that. So 3 u cubed v squared w to the fourth. And then here, I'm going to have 9 u to the fourth w squared. And the nice thing about the box method is you can recognize that we have like terms over here, right? So I can combine these two. So then I'm going to have a total example of u squared v to the fourth w cubed minus 6u third to the third v squared w to the fourth plus 9u to the fourth w squared. Now again, this is still times v to the negative second power, but it's important for us to recognize or to remember that v to the negative second is the same thing as 1 over v squared. So really all we're doing is we're just going to divide all of these terms by v squared. It's really the exact same thing. So why don't we just write this as dividing that by v squared. So now we basically are just going to use the rules of exponents, which is going to be dividing. You can see a v squared divides into all of these, except it does not divide into this one. So we could go back, since I use negative exponents, I would just rewrite it from there. So I'll say u squared v squared w to the 6. So I subtracted 4 minus 2 minus 6 u cubed. V squared minus v squared is going to be v to the 0, which is just 1. So that'd be w to the fourth plus 9 u to the fourth w squared. And then since there's a divided by v squared, I'll just use v to the negative second. So hopefully, again, that was another heavy algebra problem. Hopefully I didn't make a mistake in there. All right, moving on to the last question for Ellen is, again, another one just going to be distributive property. So again, you're just going to distribute here. The only really difference in this case is, you could use this rational exponents. Remember, you could rewrite this as x to the 3/2. So whenever you have a radical, just rewrite it as a rational power. And then I always like to also rewrite them as positive exponents. Okay, so now I'm going to distribute this times both of these terms. And just remember, when you multiply exponents, you add the powers. So remember, this is x to the first power. So 1 plus 3/2, you can just really rewrite that as, so what is 3/2 plus 1? Well, just change 1 to 2 over 2. That's going to be 5/2. So therefore, this is going to be, when you distribute this now, so we're going to multiply this term by that and that. So therefore, we'll have x to the 5/2, which is the same thing as the square root of x to the 5th, if you're following that. And then nothing happened with the y, and nothing happened with the z. However, in the next expression, we have x squared times x to the first, so that's going to be x cubed. Y squared, you can see that that's in the denominator, right? So y squared divided by y squared is just going to be y to the 0, which is 1. And then we're going to have z times z cubed, so that's going to be z to the 4th. So hopefully, Ellen, that helped you out as well. All right, let's go ahead and take a look at the next one from Andy. So Andy posted a question that said, if p to the 6th and q to the 9th and r to the 10th is greater than 10, which of them must be greater than 0? Or which of these statements must be greater than 0? And the answer was p squared times q. He gave me like a whole bunch of other ones from there. But I think he was just having trouble with that. And again, p, q, and r are real numbers. We don't know what they are. But how do we know that p squared over q has to be 0? Or has to be greater than 0? Sorry. So that all comes into what is the power that p, q, and r are raised to. So if you look at p and r are both raised to an even power. What that means is it doesn't matter. P to the 6 is greater than 0, no matter what the value of p is. If p is negative, it's greater than 0. If p is positive, it's always going to be greater than 0, because anytime you take a number, positive or negative, and raise it to an even power, it's going to be greater than 0. So p to the 6 is greater than 0, and r to the 10th is greater than 0. So what that means is if this expression is going to be greater than 0, not 10, I don't know what the heck I'm doing there. If this expression is going to be greater than 0, what that means then is q has to be greater than 0, because q is only greater than 0 when q is positive. Q is less than 0 when q is negative, right? So that's different from p and r. So what that means is no matter what, p and r doesn't matter. It really doesn't matter. the only thing that matters is q because it's raised to an odd power. So if q is negative, that whole expression would be negative. And if q is positive, then that whole expression would be positive. So since p is still being squared, it doesn't really matter what p is. So that means the only one that has to be greater than 0, or what must be greater than 0, I can't remember exactly how the problem was phrased, is going, well, it's going to be that p squared over q. And that's just because q has to be positive for the expression to be positive. And it probably would make more sense if I wrote down all the answers, but I apologize. I don't have I don't have the time to go and rewrite all of those. The next one comes from Anastasia, which was asking about the limit. She did ask for a little bit more of like the definition of limit, or the formal definition, which I don't really teach too much into my class because, yeah, it gets really, confusing for a lot of students. And also even like my description, like when I'm teaching it, I just see those like glazed over eyes. So a lot of times I just kind of get into picking up from where I teach it and from pre-calculus. But for the open live and stream, I am just going to try to give you some quick little tips here to understand. So one of the problems though that she was having or asked me about was the double angle formulas. So the cosine, the double angle of cosine, I'm not going to go over where they come from or how they come from, but there are some double angles, especially in calculus, that you are going to want to know. And especially something we cover in pre-calculus. And I get a little bit more in depth in pre-calculus, but definitely for calculus, you're just going to want to make sure you know them. And the cosine has 3 double angle properties. So I just wrote down one. I didn't remember all of them off the top of my head, so I had to do a quick little search. But definitely, if you're taking the course, make sure you have those written down or very readily available for you. Now, when you're evaluating the limit, the first and best thing you want to do is plug it in, right? Do direct substitution. The problem here is when you plug this into this equation, you're going to make the denominator equal to 0. Because when you plug in negative pi over 4 into that limit, you're going to multiply by 2, so that'd be negative pi halves. Hopefully you know at the unit circle, the cosine of negative pi halves is going to be 0, and you cannot divide by 0. So what that's going to help us do then, or what that's going to make us think is, well, how can we simplify this? Well, when I see the double angle for cosine, I recognize I could use the double angle formula, but I also recognize I see a radical. And one of the tips that we work on in calculus is when you see that radical, a lot of times what we're going to want to do is simplify by rationalizing out the radical. So that's what I'm immediately going to try first. Because if I recognize this, I recognize this is the double angle formula, one of them. But still, it doesn't help me out. Like still, when you go ahead and plug that in there, you're still going to get, if you do the negative pi halves in for there, and then which is square root of 2 over 2, square it, you're still going to get 0. So it's not solving anything. That means we need to simplify this. So what I'm going to do is I'm going to multiply by 1 minus the square root of 2 sine of theta. Okay, so I'm going to multiply 1 minus square root of 2 sine of theta on the top and the bottom. Now in the top here, again, we'd recognize that difference of 2 squares. What's nice again about that is that we can just go ahead and multiply the first 2 terms together. So that's going to be 1 minus 2 sine squared of theta. And what do you know? That's the double angle formula. That's cool. Awesome. Now, so again, you could maybe just rewrite that if you wanted to. But let's maybe just say I could rewrite cosine here as 1 minus 2 sine squared of theta. Okay, cool. And then, but again, remember you had to multiply on the top and the bottom. So on the bottom, we have 1 minus square root of 2 sine of theta. All right. Now, you're not going to want to distribute this. You could, but we already recognize we have the same expression in the numerator and denominator. So I'm going to divide them out. So simply, I am just looking at now the limit as x approaches negative pi over 4 of 1 over 1 minus the square root of 2 sine of theta. Now, let's go ahead and apply direct substitution. So by applying direct substitution, all I'm simply going to do is I'm going to plug in pi over 4 into that expression. And now I'll simplify. So negative pi over 4, looking at the unit circle, that is going to be a negative square root of 2 over 2. So 1 over 1 minus the square root of 2 times negative square root of 2 over 2. Negative square root of 2 times negative square root of 2 is going to be a positive 2 over 2, which is going to be a, so that's going to give me 1 over 1 plus 1, which is 1/2. And there you go. The next limit is, again, the nice thing about or the tricky thing about the cosine is you can use different ones. So, or you can use different double angle formulas. So in this case, you have cosine of 2x. I recognize this cosine of x minus sine of x. So me and my brain said, oh yeah, let me go and use this double angle formula for that. And then what I'm going to do is actually the reverse of the difference of two squares. I'm just actually going to factor it using the difference of two squares. So I can rewrite the numerator as cosine squared of x minus sine squared of x all over cosine of x minus sine of x. Now what I can do in my numerator is I can just go ahead and factor that out, or the limit as x approaches pi over 4. So actually, and then actually I can simplify that, yeah. So that's going to be cosine of x minus sine of x all over cosine of x plus sine of x all over cosine of x minus sine of x. So again, now you see that those divide out. And again, this wouldn't work because if you were to plug in the pi over 4 for cosine of x minus sine of x, that would be 0 again. But now, when I have this as cosine of x plus the sine of x, now I can just go and apply direct substitution. So that's going to be the cosine of pi over 4 plus the sine of pi over 4, which is square root of 2 over 2 plus the square root of 2 over 2, which is 2 square root of 2 over 2, which is equal to square root of 2. And there you go. Whew, that was long. All right. And then the last question here, I'm not sure. The student sent me a work, and I'm not sure if it was their work or their friend's work or their teachers. But basically they're trying to understand what the work was happening, like as far as proving multiplication to prove equivalent fractions. And they didn't understand where this 1/8 came from. And so to understand the problem, so we have 4 times 3 plus 6/8. That was at least the problem. That was the top thing that they showed me. So again, what we've already kind of covered in this live stream is apply distributive property, right? I mean, just distribute there. So when you distribute, you have 4 times 3. So 4 times 3 is 12. And then really you're doing 4 times 6/8. Now, how do you multiply 4 times 6/8? Now, typically, at least in the high school realm, I just say, you can rewrite 4 as 4 over 1 and multiply numerator times numerator. So that's to be 24 over 8. And then you can go ahead and simplify, which would be 3. Okay. However, what this teacher or whoever did is they broke up 6/8 as 6 times 1/8, which is true, right? Because if I had 6/8 equals, that's the same thing as 6 times 1/8. Because if I was to multiply 6 times 1/8, I would just change it over 1. I'd multiply straight across. So that's all they did. So they broke that up into 6 times 8. And then therefore, then you can just multiply the whole numbers 4 times 6. So I'm not sure if this really helps out because 12 times, 4 times 6 is going to be 24. And then you still have to multiply by 1/8. Well, and then again, multiplying by 1/8 is the same thing as dividing by 8. So that's going to be really the same thing as 24 over 8, which is 12 plus 3. 24 over 8 is 3. So my final answer is just going to be 15, which is the same thing that I would have gotten anyways because I had the 3 there right before. So I'm not sure if they simplified anything. Obviously, I'm assuming whatever their work was based off of either some instruction that they have been going on or some instruction they've been going on or the some instruction they've been working on or something that they've been teaching inside the classroom. Okay, but anyways, guys, that is it for the live stream. I think I'm going to now go ahead and check into my chats and see what the heck has been going on. So that live stream didn't work, or as far as with that. Let me go and see if I can copy that paste. So for those of you that want to see those testimonials, and also, I'm not sure if any of you guys noticed that the live stream, some of you guys caught into my private live stream on this Saturday. Hopefully that was beneficial to you. I was actually at quite a good scare at, or a good amount of people at 8 a.m. on Saturday morning. I was surprised. I was not thinking I was going to have that many people show up for a live stream in the morning. It was supposed to be private. I go on my members area for YouTube. I go live once a month and just kind of do a private live stream where there's just not as many people up from there. But I forgot to change the settings, so it was open to everybody, and a whole bunch of people dropped on, which was great. But yeah, just not intended. So let me go and see. I am done, but now I got to get your comments, because if you guys have been joining me on my comments, I want to say hello. So let's go ahead and get back into it and see what I have going on here. So that doesn't show up on there. All right, that's kind of annoying. No. Monitor. All right. I want to see. I want to see my live studio. There's my chat. I can check on your chat and see if I can get your guys. If you guys post in a chat, I'll see if I can ding. Oh, well, that's not very nice. I was looking for happy ones. Well, hi, Zach. I'm mentioning you. I don't know. I'm trying to figure out. Yes, that's a live. Oh, no, I don't want that. Oh, that better be a preview. What is going on? See, this is why I wanted to try these things. Oh, man. So weird. Okay. Interesting event. I'm going to have to see, update my titles. Yeah, I know it. Update my titles. That's all right. I can just go and connect it. All right. I already got that one done. Oh, come on, move that. Open Q&A week 5. Oh my God, that's very old. All right, so let's go ahead and update that. Cool. My description. Cool. So updated the description, at least in my YouTube, for you guys. But I still cannot get into the live stream from you guys. Let me just go to my. So weird. I'm just playing around with it, guys. I'm trying to get to my chat. I can see you guys posting in there. I can see that one, live Q&A. Jeez, oh man. I don't know why. There we go. So at least, all right. So this live stream has been edited. So I think when I do these, when I schedule them, I just got to go back through the all right. I'll just need to make sure that I go back through Restream when I go ahead and post these, because I think I scheduled this through YouTube, not through the other website. So I do apologize. I did see some of you guys though on the, so I can post in there. Man, this is going to be, I don't know why. Doggo, you're saying? Huh. So weird. All right. Yep. All right. That's just going on there. Weird. All right. I'll probably, I'll have to definitely go and play around with this. I'll probably do a couple more bonus live streams to go ahead and get this all figured out. And cool. All right, guys. Well, I apologize for that. I'm a little bit like flustered because I don't have my chat that I want to have. So I'm not like used to being able to go over and manage with you, or like kind of look at my live streams. It's kind of a little annoying because it's just not something I'm like used to, but it's something I was like, I need to get this figured out. So I wanted to kind of do that and get to it, but that's things. But what the problem with that though is now it's not allowing me to go ahead and go for those live streams. So maybe it's looking at the events. All right. Either way, guys, hope you enjoyed the live stream, and I will check in with you guys next Sunday where I'll do my open live Q&A. I'll see you guys then. Cheers. I got to turn this off. It's all